Hello everybody and welcome back to your computer science tutorial. This is section 3 video 6 and this will be the last video for this section, but this is one of the more important videos of this section because we're going over something very big to programming. Although you might not use it much now, this concept is very important, and it's the idea of loops. So now you're probably wondering, well, what is a loop and what does that have to do with this big red word repetition here? Well, in programming, you tend to have to do a task a lot of times. And actually, that's very difficult without loops because let's say you want to check if a number was less than another number and you had a bunch of different variables you want to do it for. Well, you could send those variables through a loop and it'll spit out an output. Or let's say you wanted to make a grid appear on your screen and you needed to draw lines, and as you were drawing the lines you needed to change their position. This is where loops become very useful because they're great at changing information that you know what you want to change about it, and it's in fixed increments. And even in you can do some interesting loops where they'll do technically fixed increments, but they can vary based off other inputs. And so I'm babbling now. So let's just hop into Unity. So if you remember our okay, so for this tutorial I made another fireball, but I pulled out the rigid body in it and the point ladder inside the root object. So now, and also the smoke as well. So now it's just what the flame would look like. So if I drag this into the scene, you'll get a good look. You'll get an understanding of what I mean. And here's our little fire there. And let's say we want this fire to... we want more of it. Simple as that. This one little piece of fire isn't big enough for us. We want to make more of them. Well, if you were to look at our code to create fire last time, it's quite a lot of code to do a very simple task. And if I get to it, and the thing is that we shouldn't have to keep typing in this line with slightly altered positions, because we know where we know where we want our fire. Let's say we want our fire like 1 unit away from the last fire. Well, then that's what we got to do. But we can't just do that every time. That, like, what if we want 100 pieces of fire? And this is where the idea of for loops become vital, because as a programmer, you don't want to waste your time doing a task that you can automate via the computer. So that's what we're going to be doing today. Okay, so we're going to hop right in. I'm just putting this under coding fundamentals because this is one of the more important scripts. And I know it's called for loops, but another way you'll hear me reference this is recursion. Just an event that reoccurs. Recursion. Okay, so first we're gonna create just one of these objects, because, well, we need to start somewhere. So let's start with the code to create one of these objects, and let's do it on our start function. So right when the game starts, it's going to do this. And right now we need a object to clone. And I'm making a variable with and I'm going to declare it as obj, and it's going to be of type game object. Very similar to our instantiation. And the only thing we're going to do is we're going to create a new object, and we're going to call it clone, and it's going to be of type game object, and it's going to equal to instantiate, and we're going to put in our object, our obj. It's actually a very bad naming scheme, because a lot of other things, and you use object, so it can get a little confusing, but I think we'll be fine in this case. Transform.position, this is where it's going to be, and transform, if I can spell transform right, dot rotation for its rotation. And for those of you that have no clue what's going to happen, I'll just run this script really fast. We'll delete that. And, that's weird. Let's clear that. Let's put it on our cube right here, and we'll add our script, and our script is called recursion. It's right there. Let's add it. And now it's going to ask us if we need a input, and we're going to put in this simplified Firebase. The reason why I simplified it is because if you are to recreate this 1,000 times, well, rigid bodies, as I said before, they take up a lot of data. So do colliders. So do mesh renders. So do the objects beyond, like lights. Lights require a ton of data. So we just simplified it down so it won't have any lighting effects, but because it looks like fire, it will create an optical illusion. And that is my crazy dog. I hope you can't hear him. And if we were to run it, you'll see that it'll create a fire right on top of the cube. Now our cube's on fire. Awesome. We need to make more of them because we like bigger fire. So here's the new stuff. How many do we want? Well, let's say we want X amount. And we'll call it a row. And this row value, let's say it's a whole number, so it's going to be an integer type, not a float. And we'll set it to 5. And we want it to expand in the x direction by 5, because that's what a row is. It's something in the x. So for variable x, we want it equal to, it's going to be an int. It's going to be equal to 0. You can do more than just ints, but ints are the simplest to work with when you first start out, so I suggest using them. And while x is less than or equal to rows, the equal to is very important. If you do not have the equals to, it'll just go from 0 to 5, so we're actually going to end up with 6 rows. If you started at 1, you'll have exactly 5 rows. So, and then our final thing is this bit of code right here, x++. Now you're probably wondering, wait, what does that x++ have to do with anything? Like, I kind of get that we need a number to check. And basically, what a for loop is, it's an if statement that just repeats over and over again and does it as long as a condition is met. This is your condition, so as long as this is true, I'm dragging in that, I don't want to do that. As long as this is true, we want to do this. And each time we do it, we want to add something to x. You could also subtract from x. You can divide by 2. You could do a lot of different things. But right now, we're going to add, because adding is easy. And so the last thing we need to do is it's going to put 5 objects, but they're all going to be in the same exact position. So we're just going to add a vector to the position. And you could do this. This is all legal. I swear to God. And we'll call it x. If you wanted a specific distance between your flames, you can multiply it by some distance. I'll make a variable for that, and 0, 0. And we'll make that distance variable. We'll say distance is a float, and we'll set that equal to, I don't know, 1. Just as a native start. And if we load this up, and it's not going to tell me I have errors, and we're to run this, see, right on the start, we have this cool looking wall of flames now. You also notice that it's also shifted over a ledge, which is an effect of us starting our row at our x value at 1 instead of 0, which is why I started by 0 on accident. But we have 5 flames now. And they're all in this nice little row which we wanted. But now let's say this row isn't high enough. We're going to add a little more complexity to this code. But it's not going to get it's not going to become much harder though to understand. So let's tab this over. I'm very excessive about my tabs. I don't know why. Actually, I do know why. When I first started programming, the language I was learning in, it didn't work unless you knew how to tab properly, which was like, just not a good time. And we're gonna start from 0 this time because I want it centered on that cube, just so we have a reference point. And so it's the same thing, but this time we're gonna be declaring the variable y, and we will check to see if y is less than or equal to columns, or just cols. And every time we do this, we want to add 1 to y. And let's add the curly braces in the right direction. And we have to add a variable for columns now. Typically when you write code, as you saw right now, is that I'm writing this all from scratch. I'm making numbers because I know I need them, and I have an error somewhere, semicolon. And as I'm moving along, I know that I need this number in my head, so I'll just write the name of the variable that I need, and then I'll just fill it in later. That's typical coding practice. And you see, it got really, really dark, but like not any higher. Why is that? Well, because we have to add the y distance now, which is y times the distance. Same code, very simple, not distance joint. See, there's a lot of these cool things in Unity, like distance joints and crazy wackadoodle things that I'm not going to be able to cover in this general class because it would be so much to cover. And there's our very high. And you also see it's a little less laggy this time. When you spawn a bunch of flaming objects on top of each other, Unity sometimes gets confused. Just FYI. And so there's our little fire panel. But now we have rows and columns. And, well, let's make it a big box then. And let's look on lowering that box too. So let's make it expand in the Z direction now. Now, the reason why I say Z direction is because, I could just add that there, is because there's rows, there's columns, but there is no term for the Z direction of an axis other than applicate. And by God, I hate the word applicate. I don't know why. Just I don't like the word applicate, so we're just gonna say Z. And while Z is while Z is less than or equal to Z, if you're wondering where I got that from, and we're gonna just add some to Z. Z was how British people say Z, because they don't say Z. I don't know why. It's just magic. And do distance. Let's save that. And now if we were to run this, I have an error because I never defined Z. Variable Z is going to be an int, and that int will equal 5. So now we have a 5 by 5 by 5 box, which is 125 game objects. Yes, I just did that all in my head. That's a long list, but look how cool it is, and look how cool it is. We got this burning box of doom, and actually, if we were to move our cube down a little bit, we could go inside our box. And the cool thing about for loops is that after, you'll see when I enter this, it just looks like I'm in a giant pile of flames. I can't really see much. I'm disorientated. and I want out. But the cool thing about for loops is that you can add if statements inside the for loops, so it'll only run sometimes. For example, if I were to, let's see if I remember how to do this. So we want to not draw, we only want to draw this if, well, what's the inside? The inside is anything that's not on the surface. So that means, I'm trying to think of the logic behind it. That's a good task for you. Try and make your box hollow. I'll give you a hint. It has to do with something with if the x equals this, if the y equals that, if the z equals that, or like a range like that, then you don't want to do the code. So you do the opposite of that code. So you could say if, I'm going to do it right now, aren't I? If x is equal to 0, so it's on the outside layer, or if x is equal to I think 5, continue on, and then inside that, if y is on the top of the bottom, it's the same, it's going to be the same code. If x is equal to, no, not if y is equal to 0 or y is equal to 5. So this is like the outside edges. And then you do the same exact thing with the z. And then if the z or the z is equal to 0 or, and you could set this to, you could set the second part to the actual name, so you wouldn't have to re-hard code this every time, which is much better practice, actually. And I'm actually going to do that so we can make our box a little bigger, because I think it's going to end up a little small and just not look pretty. And row, and then just stick this line right here. Just copy that out, delete it, and inside right here, look at all those tabs, those beautiful tabs. Now we can't even see the function, whatever. And we're going to have a lot less objects now, and I have an error. Because I probably mocked my equal sign. I did. And that might fix everything. Or it might not. No, it did. Okay. And if we were to run this, I should have a lot less game objects. Yeah, you see. Not quite the effect I was hoping for. You'd have to play around with it. Oh, I know why. I embedded them in each other. You actually aren't supposed to do that. I lied, I'm sorry. If you click Control Shift Tab, not Control Shift Tab. Don't click that. If it's a Control Tab, no, it's not Control Tab. If it's Shift Tab moves things back. Nifty trick. I learned it not too long ago. It's very useful. And let's just copy this here, pull that out. And I actually know the problem with this code right here. I ran it every single time, which, well, you don't need to do that. That's actually what's causing the error there. You actually need to just do the check once, see if it passes any of those tests. Well, then you want to just use that object, because then it's on the surface area. Okay, and then if we, let's pretty that up. So you can see how these if statements can get really complex really fast. Or these for loops, actually. I should be saying the right thing, and I didn't save it. How complex these for loops can get. And okay, so right now Unity's seeing this clone variable, and we could have it multiple times. So you just rename it, stick a number or something in it. And this isn't quite optimized, what I just wrote, But it will produce this, which should be a fireless pit somewhere. It's hard to tell because I have no reference point inside the fiery pit of death. But hopefully you understand and get the point. It looks, actually an easier way to see would just be probably go in with it. I could probably drag that Q as a reference point. Maybe we could see it might. The cube is also white, so. Oh, did it not work? It might not have worked. I'll be honest, I'm not sure if this. I'm writing this right out of my head right now, and it might not be working, and it is really hard to tell. I don't think it is working, or that the what might be our problem is that the way our fire is set up is that it goes up really, really high. So if we actually were to increase our distance here, it would look a lot better. Like a lot better. So if we were to increase our distance to 5, you would see the effect much more pronounced, and it'd be visual. The flames would be a lot more spread out too, like you see. There's our fireball cage. And the bottom, you could also take the bottom layer out by removing the y equals 0. But the problem with this right now that I can automatically tell is that there's two fireball objects whenever y equals 0 and x equals 0, or whenever like right here. It's not an optimized code, still works though. And that's an example of very complex for loops. They can get a lot cooler. You can use for loops to make circles or a bunch of other things. They're really limited by your imagination and your ability to use them. And you'll sort of see as you go on, like this actually looks really cool. But I'm liking this now. I might have to keep this. But you can also use them make like fireball spin or something cool like that. It's really limited by your imagination on how you're going to use them. You can make all of these spawn like blocks that come back together to the original. Oh my gosh, I'm just imagining now. Okay, but that's it for this tutorial. I hope you guys enjoyed.